Welcome back. So this is the last part of our module number 4, which is shear and moment equations and diagram. So this is still area method. We're going to draw our shear and moment diagram by using the area method. So we have here an overhang beam, which is still simply supported at pin at point B and a roller at point D. So this is quite complicated compared to our previous examples. We have here a uniformly distributed load from point A to point B, which is 400 pound per foot. And we have here a 200 pound foot uniformly distributed load from point C to point E, and we have a point load of 400 pounds at point C. So the first thing that we need to do is to draw our free body diagram and determine our reaction. So the reaction at B is a pin, so or the support at B is pin, so I'll be expecting that I'll be having a B vertical and a B horizontal. Okay, so this is B horizontal, then I'll have here E vertical. Okay, so the next thing that we need to do is to solve for our reaction. So summation of moment with respect to B is equivalent to 0. All forces rotating clockwise should be positive. So what are the forces that are going to rotate? So we have 40, okay, and 400. So 400 rotate siya ng counterclockwise. So negative 400 times a lever times a distance of 2 feet and a lever arm of 1 feet because it is acting at the center. Okay, so plus PC will be rotating clockwise, so that would be plus PC. Substitute na natin. No? Let's substitute it. Plus 400 times a lever arm of 1 minus, still it is plus. So plus 200 times a distance of 6 feet, and the lever arm is, take note, it is acting at 3 feet for the distance of 6 feet plus 1, so the lever arm is 4. Then E vertical would be rotating counterclockwise, so that is negative E vertical times a lever arm of 7 feet. Therefore, E vertical is equivalent to, correction, yung E vertical, it is not 7 because E vertical is located here. So this is E vertical, it is not located here. Mali. So that should be 5 feet. Okay, so 5 feet. E vertical is equivalent to 880. And that is in pounds. Now to solve for the A vertical, summation of forces vertical is equivalent to 0. All forces pointing upward should be positive. So we have a downward force of 400 times a distance of 2. Tapos we have both are negative 400 pound-feet. Negative 400 minus 200 times a span of 6 feet plus B vertical plus 880 is equivalent to 0. B vertical therefore is equivalent to 1,520 pounds. Okay, so we're now ready to draw our shear and moment diagram. So we have here at point A, so for the shear, we have shear at A is equivalent to 0. Then we have shear AB is equivalent to 0 minus, because our load here is pointing downwards. So minus 400 times a span of 2. So that would be 400 pounds times 400 pound-feet. Okay? Pound per feet, magka-cancel out yung feet. And that is equivalent to negative 800 pounds. Okay? So from 0, take note, this is our point of reference, that is our x-axis, and that is 0. So you have here negative 800. So we have there negative 800. Then the shear at B, shear B is equivalent to negative 800 plus our reaction, which is B vertical 1520. So 800 is equivalent to 720. So from negative 800, aakyat tayo ng positive 720. Okay. Do we have a change of load from point B to point C? There is none. So we have shear BC is equivalent to 720 minus 0 is equivalent to 720 still. So that will still be a straight line from point B to point C. Okay. Okay. Now, we have here a point load of 400 pounds. So 720 minus 400, that would be 320. So this is 320. Okay. So shear C is equivalent to 720 minus 400. So that is 320. Now, shear CD. Shear CD is equivalent to 320 minus, because our uniformly distributed load is pointing downwards. So that is minus 200 times a span of 4 feet. And that is equivalent to negative 480. Okay? So, from positive, nagiging negative tayo. So, we have here, yon. So, that is negative 480. Then, we have a shear at the support, E, that is 780 pounds. So, shear at E is equivalent to negative 480 plus 880 is equivalent to 400 pounds. So, from negative 400, aakyat tayo ng positive 400. Okay? Lastly, we have shear that is D. Mali. It is not E vertical. It should be D vertical. VD. Okay? Then shear DE. So this should be D. And this is E. So shear DE is equivalent to 400 minus 200, the height of 200 and the base of 2. So that is the area. So 200 times 2. So that would give us 0. So it will go back to 0. Okay. So this is our moment diagram. Now, I am concerned in determining this distance. Okay, the distance here. Why? Because that distance is the place where we will be having our point of maximum shear. So this is the point of zero shear. It is also the point of maximum moment. Okay, so with that, I will also be using the area method. So if I am to project this, this is a big triangle. So big triangle is to small triangle, ratio and proportion. I repeat, big triangle is to small triangle. So by ratio and proportion, we will be having a small triangle, which is 320 is to the distance of x. So let's say this is x, is equivalent to the big triangle, which is 320 plus 480, and it has a span of 4 feet. Therefore, x is equivalent to 1.6 feet. Okay, and now I am now ready to draw my moment diagram. So for the moment diagram, it is simply the area. Okay, it is simply the area. If we are to recall from our previous discussion, point load followed by a uniformly distributed load followed by a uniformly varying load, so that would be the first degree, and it will be followed by a second degree curve. Okay, so here we have a first degree curve, therefore for the moment diagram it would be a second degree curve. So for the moment, it is equivalent to moment at A is equivalent to 0. Okay, and next we have moment A B is equivalent to the area. Ano yung area nito? We have a base of negative 800 times a height of negative 800 times a base of 2 feet times 0.5, because it is a triangle. Therefore, the moment is negative 800. So, ipa-plot natin siya dito. So, that is a first degree. Therefore, this will be a parabolic curve. Okay. Next, shear BC or moment BC. MBC is equivalent to negative 800, and this time ang moment natin ang shear natin sa segment BC is positive, that is 720 times 1. So plus 720 times 1 is equivalent to negative 80. So let's say na nandito yung ating negative 80. This is 0 degree. So it would, for our moment diagram, it would be a first degree, and that is a straight line. Okay. Next, the point of maximum moment. Okay. So for Mmax, we have negative 80 plus, take note, this is a plus, kasi positive yung moment natin dito, 320, height of 320 and a base of x. So plus 320 times a base of 1.6 is equivalent to, may nakalimutan tayo. This is a triangle, so multiply it by 0.5. Therefore, Mmax is equivalent to 176. So we plot here 176 and connect it by a smooth curve, because this is a first degree, so this is a second degree curve. Now, if you're confused whether your curve should look like this or it should look like this, then you can base it from the slope. So at the point of tangency. So for the point of maximum moment, ang point of ang tangency natin would look like this. Then dito naman yung tangent points natin. We have our tangent here. Then, we also have tangent natin dito. Hindi ko lang alam kung, wait, we need to solve first kung saan. So, verify natin kung tama yung ating diagram. So, next for the moment here, it is moment CD. So, moment max 2 D is equivalent to 176 minus, because negative na yung ating shear dito. So, minus 480 times a base of 4 feet minus 1.6 times 0.5, because that is a triangular load. So, that is equivalent to negative 400. So, if I will plot negative 400, so this is negative 800, I'll plot here negative 400. So, the point of tangency would depend on my the shape of the curve would depend on my slope. So, the derivative of moment with respect to x at point D is equivalent to the shear. Ano ba yung shear natin at point D? Okay? That is negative 480. So, it is pointing. Okay? So, it is pointing downwards. So, if I am to plot that, ang magiging itsura ng ating slope would look like this. So, this is 400, negative 480 is to 1. So, that is 480 is to 1. Now, paano magiging itsura ng curve ko so that it would be connected by a smooth curve? So, if I'll be having my curve if I am to have my curve, take note at that point, I have this, no? Pag i-connect ko yan, if I am to connect that this way, then it is no longer connected by a smooth curve, and the point of tangency is this way. So, the correct way would be, if this is the point of maximum moment, then here is negative 400 and the point of tangency is this way. It is concave upwards. So, it was still connected by a smooth curve. Okay? So, I am to connect it now by a smooth curve. And take note that it is in its second degree. Okay? Now, for here, paano naman magiging itsura niyan? Let's determine. So, solve muna natin. MDE is equivalent to negative 400. Take note that the shear is already on the positive side. So, kunin natin yung area. Height of 400, base of 2 times 0.5. So, 400 times 2 times 0.5, and that is 0. Okay? So, that is 0. So, paano magiging itsura ng slope natin? The derivative of moment at point D is with respect to x is equivalent to, the shear is 400. So, that is 400 is to 1. So, it is pointing upwards. Okay? So, that would be pointing upwards. So, that is 400 is to 1. So, to me, if I am to draw my curve like this, hindi natin mamimit yung point of tangency, or yung hindi natin masusunod yung slope sa point of tangency. So, ibig sabihin, my curve would look like this. It is concaving upwards. Now, determine natin yung slope natin sa maximum. So, the derivative of M max with respect to x is equivalent to, what is the shear? It is 0. Therefore, ang slope natin is 0. So, if i-connect ko siya na pag ganito, then hindi natin ma-meet yung criterion na it was connected by a smooth curve. Likewise with here. So, it is concaving upwards. Then, ganun din dito. So, the derivative of moment at point B is equivalent to 0 with respect to dx, and the moment here, the shear here is negative 800. So the slope would look like this, 800 pointing downwards. 800 is to 1. So tama yung curve natin. Okay? And the slope natin dito is 720. If I am to extend this, yan. So that is 720 is to 0. Bakit 720? The derivative of moment B with respect to x is equivalent to the shear. So that is 720. So 720 is to 1. So 720 is to 1. Okay? So that is how you draw your shear and moment diagram. So this is my moment diagram. Okay? And do not forget to write the degree. You have here your first degree, 0 degree, first degree, first degree, second degree, first degree, second degree, second degree. And that is your shear and moment diagram using the area method.